The journey of a satellite from concept to space deployment is a complex endeavor spanning several years. It begins with Phase 0, mission analysis, defining core objectives and initial options. Phase A is the feasibility study, establishing high-level requirements. Phase B focuses on preliminary design, outlining critical interfaces and measurable requirements. Phase C completes the detailed design of systems, subsystems, and software. Phase D involves producing engineering and flight models, rigorous testing, qualification, subsystem integration, and shipment to the launch site. Phase E covers the launch, in-orbit commissioning, and operational life. Finally, Phase F addresses disposal or deorbiting at mission end. For smaller satellites like CubeSats, this process is scaled down, often utilizing commercial off-the-shelf components to reduce costs. Customers require various satellite types based on specific needs. Communication satellites relay signals for TV, internet, and telephone services, operating in geostationary, medium, or low Earth orbit. Weather satellites monitor climate and track storms. Navigation satellites like GPS, GLONASS, Galileo, and Beidou provide positioning and timing services, typically in MEO. Earth observation satellites, usually in LEO, are crucial for environmental monitoring, agriculture, urban planning, and military purposes. Scientific satellites conduct space research, with orbits varying by mission. Reconnaissance or spy satellites gather intelligence, often in LEO for detailed imaging. Space exploration satellites explore celestial bodies and relay data. Other types include experimental tether satellites, recovery satellites for returning payloads, and biosatellites for biological experiments. Satellite program costs vary dramatically based on size, purpose, and launch requirements. Designing and manufacturing a large communication satellite can cost over $320 million, while small CubeSats can be built for under $53,000. Launch services range from $10 million to $400 million. For example, a small launch vehicle costs around $13.5 million to lift 976 pounds into LEO, whereas a heavy launch vehicle costs $165 million for 39,648 pounds. SpaceX offers small satellite rideshares for as low as $350,000 for 50 kilograms to sun-synchronous orbit. Beyond manufacturing and launch, ongoing maintenance, ground facility monitoring, and bandwidth contribute significantly to expenses, potentially exceeding $1.5 million annually for 36 megahertz bandwidth. Finally, government satellite programs,